The ratio of heights of two containers that are geometrically similar is 2 to 3. If the surface area of the smaller container is 80 square centimeters, find the surface area of the larger container. Hello and welcome back to my channel. This is Donald Siami, author of Hidden Mathematical Genius Within Revealed. Today we are looking at calculations involving similarity and congruence. Okay, so we have this question. We are told that two containers are similar and the ratio of their sides is 2 to 3. Okay, we have the smaller container is 80 square centimeters and we want to calculate the area of the larger container. So now, to calculate for area, we're supposed to have ratio of areas, and what we have here is ratio of sides. So what we should know is that ratio of areas is just equal to the square of ratio of sides. So we need to square the ratio of sides. So ratio of area will be 2 squared is 4 and 3 squared is 9. So the ratio of areas is 4 to 9. Okay, the smaller container is 80 square centimeters. So the smaller will correspond to the 4 here. So you put 80 square centimeters there. 2. We are looking for the larger container, so you put x there. Then we can cross multiply. So you say 4 multiplied by x, you get 4x is equal to 80 square centimeters multiplied by 9. Okay, so for us to remain with x, we are going to divide 4 both sides of the equation. So over 4 on this side over 4. So x is equal to, what is 4 in 80? Yes, 4 in 4 is 1. 4 in 8 you get 20. And 20 multiplied by 9 you get 180. So we have 180 square centimeters. So that is the surface area for the larger container. So what you should remember is that to calculate for area, you're supposed to have a ratio of areas. And ratio of areas is just the square of ratio of sides. We go to question 2. A cylinder with diameter 2 centimeters has a volume of 5 cubic centimeters. Find the volume of a smaller cylinder with diameter 8 centimeters. Again, what we should know is that diameter is also a side. So we have ratio of sides even here. Okay, so we have 2 centimeters for the smaller and 8 centimeters for the larger. So if we simplify that ratio, we can cancel out the centimeters. Then what is the highest common factor for 2 and 8? Yes, that is 2. So 2 in 2 we get 1, and 2 in 8 we get 4. So 1 to 4 is the ratio of sides. Now here we want to solve for the volume of a cylinder. This should be a larger cylinder. Okay, so again, for us to calculate volume, we need to have ratio of volumes. And here we have ratio of sides. So ratio of volume, ratio of volumes is just equal to the cube of ratio of sides. So it's the cube of ratio of sides. Since we know that volume, the units for volume is a power 3. So you just cube a ratio of sides. Then you have ratio of volumes. So 1 cube, you get 2, 4 cubed, that is 64. So we have 1 to 64. So that is the ratio of volumes. Okay, now the smaller volume there is 5 cubic centimeters. So you put 5 cubic centimeters there. Then you're looking for the larger cylinder, so you put x there. Then you cross multiply. So 1 multiplied by x, you get x is equal to, what is 64 multiplied by 5? So 64 multiplied by 5. 5 multiplied by 4, you get 20. Carry 2. 5 multiplied by 6, you get 30. 30 plus 2, you get 32. So you have 320 cubic centimeters. So that is the volume of the larger cylinder. We go to question 3. The ratio of the surface areas of two cubes is 16 to 25. Okay, so that one is the ratio of areas. That is 16 to 25. What is the volume of the smaller cube if the volume of the bigger cube is 500 cubic centimeters? Now, here we have ratio of areas. So what you do is that we are going to convert this ratio of areas to ratio of sides. Then from ratio of sides, then we take it to ratio of volume. So from ratio of area to ratio of sides, we are going to square root. Okay, so to get ratio of sides, you just square root the ratio of areas. So ratio of sides is equal to the square root of ratio of areas. Okay, so we are going to have the square root of 16 is 4 to square root of 25, that is 5. So this 4 to 5 is the ratio of sides. Now from this ratio of sides, we need to get ratio of volumes, because we need to calculate volume. So ratio of volumes, you just cube ratio of sides. So 4 cubed to 5 cubed. 4 cubed, you get 64, and 5 cubed, you get 125. So here, we are told that the volume of the bigger cube is 500 cubic centimeters. So bigger is 500 cubic centimeters. So you put under the bigger ratio there. Then since we are looking for the smaller cube, you put x there. Okay, then you cross multiply. So it will be x multiplied by 125, you get 125x is equal to 64 multiplied by 500 cubic centimeters. Okay, then to remain with x, we divide both sides by 125. So over 125, and this side over 125. So 125 and 125 cancels out, remain with x is equal to 125 can go in 500, and that is 4 times. So there it's 1 in 500, you get 4. So what is 64 multiplied by 4? 4 multiplied by 4 is 16, 6 carry 1, and 4 multiplied by 6, that is 24, plus 1 you get 25. So you have 256 cubic centimeters. So that is the volume of the smaller cube. Okay, we go to the next questions. Okay, we have two tins are geometrically similar if the ratio of their volumes is 27 to 64. Find the ratio of their curved surface areas. Okay, so since we have a ratio of volume, this ratio of volume should be converted to a ratio of sides. Then from the ratio of sides, we can get ratio of areas. Okay, so from ratio of volume to ratio of sides, you just cube root the ratio of volumes. So it will be cube root of 27 to cube root of 64. What's the cube root of 27? So cube root of 27, you get 3. And cube root of 64, you get 4. So that is the ratio of sides, 3 to 4. So from the ratio of sides, we can now go to ratio of areas. So ratio of areas, you just square ratio of sides. So it will be 3 squared to 4 squared. 3 squared, that is 9, to 4 squared, that is 16. So the ratio of their curved surface areas is 9 to 16. Okay, next question. The base areas of two containers that are geometrically similar are 80 square centimeters and 180 square centimeters respectively. If the capacity of the larger container is 54 liters, calculate the capacity of the smaller one. Okay, so here again we have a ratio of areas. We have 80 square centimeters to 180 square centimeters. So now let us first simplify this ratio of areas. Okay, so we can cancel out the square centimeters. You can cancel out the 0 there and the 0 there. What is the highest common factor for 8 and 18? Yes, 2. 2 in 8, you get 4. And 2 in 18, you get 9. So 4 to 9, that is the ratio of their areas. Okay, now what we are looking for is volume. So to get volume, we're supposed to have a ratio of volumes. And here we have ratio of areas. So this ratio of areas should be converted to a ratio of sides. Then from ratio of sides, we take it to ratio of volume. Okay, so ratio of sides is equal to the square root of ratio of areas. So you square root the ratio of areas. Okay, square root of 4, that is 2, and square root of 9, that is 3. So 2 to 3 is the ratio of sides. The ratio of volume, you now cube the ratio of sides. So it will be 2 to the power 3 to 3 to the power 3. That is 3 cubed. So 2 cubed you get 8, and 3 cubed you get 27. So 8 to 27 is the ratio of volume. Okay, now here we are told that the larger container is 54 liters. Okay, so 54 liters is corresponding to 27 there. So we put 54 there. That is 54 liters. So smaller one, you put X there. Then we can cross multiply. 27 multiplied by X, you get 27X is equal to 8 multiplied by 54 liters. Okay, then to remain with X there, you say over 27 and over 27. 27 and 27 cancels out, so we have X is equal to, okay, 27 can go in 54, that is 2 times. So we have there it's 1, there 2. And 8 multiplied by 2, you get 16. So we have 16 liters. So that is the volume or the capacity of the smaller one. Then the last question. The ratio of the volumes of two similar solids is 64 to 27. The surface area of the smaller solid is 180 square centimeters. What is the surface area of the bigger solid? So first thing there, we have ratio of volume. So that ratio of volume should be converted to ratio of sides. Then from ratio of sides, we go to ratio of areas. Okay, so we have volume, ratio of volume, that is 64 to 27. Then ratio of sides, you just cube root the ratio of volumes. So it's the cube root of 64 to the cube root of 27. So cube root of 64, you get 4. To cube root of 27, you get 3. So ratio of sides, we have 4 to 3. Okay, then we convert that to ratio of areas. So ratio of areas, you just square ratio of sides. So it is 4 squared to 3 squared. Okay, so 4 squared is 16 to 3 squared, that is 9. Okay, so we are told that the surface area of the smaller solid is 180 square centimeters. So the 180 will correspond to 9. So you put down there 9 square centimeters. So the larger container will correspond to, it's a larger solid, the bigger solid will correspond to 16. So you put x there. Then you cross multiply. Okay, so we have 9 multiplied by x, you get 9x is equal to 16 multiplied by 180 square centimeters. Then for us to remain with x, we are going to divide by 9 to both sides of the equation. So you say over 9 there and over 9. 9 and 9 will cancel out, so we have x is equal to 9 in 180. 9 in 9 is 1. 9 in 180 there is 20. And 2 multiplied by 16, you get 32. Plus a 0 there, so we are going to have 320. So we have 320 square centimeters. So that is the area of the bigger solid. So this is how you perform calculations to do with similarity and congruence. Thank you so much for your time.